In this video, we'll generate the Gaussian integral using the Maclaurin Series sum, ERF function, and the Gauss function. We begin with the Maclaurin Series sum, which is the summation of a times x to the power 2n plus 1, where a is equal to negative 1 to the power n over n factorial times 2n plus 1, and the value of n will be from 0 to infinity. In this case, we can reach up to 16. And the coefficient will be equal to array formula minus 1 to the power n divided by the denominator has two parts, n factorial and 2n plus 1. So factorial of n times the quantity 2 times n plus 1. Now we can complete the Maclaurin series sum expansion, which is array formula. Series sum of the x values raised to the power 2n plus 1, where 2n plus 1 starts from, at n equals 0, it's 1. So it starts from 0 and incremented by, so the next will be 2 times 1 is 2 plus 3. So it's 3, 1, 3, 5, 7, 9. So the increment is 2. And the coefficient will be this range. And we continue with the ERF function, which is array formula, ERF of the x values. Enter. And the coefficients, or the Gauss function. So array formula, Gauss of the x values. And we'll just complete the polynomial regression. So this is transpose from 0 to 8. And the LINEST matrix will be equal to array formula of the x values raised to the power 0 to 8. And LINEST, this is LINEST dot y and dot x. Again, this is LINEST dot y and dot x. Enter. Again, this is LINEST for the Gauss function in that x. So here you have the trend line, the polynomial regression coefficient using LINEST. We'll chart this. So insert chart. And we will use scatter chart. And the trend line will be polynomial to the 8th degree. And we'll check this column A as labels and letters, and use the equation as label. The legend will be at the bottom. And we'll change the color of the yellow, the Gaussian function, the Gauss, to green. So here we have the trend line and the polynomials. Next, we modify the ERF to match the Gaussian integral. That is 0.5 times square root of pi times ERF. So starting with 0.5, 0.5 times. Next, that will be times square root of pi. Now the data sets are the same, and the polynomial regression are the same. Continue with the Gauss function. In the Gauss function, we have square root of 2 for the x, so multiply this by square root of 2. And then multiply this by square root of pi, so times square root of pi times square root of pi. Enter. Now all three are the same data set. All they are in the same trend line, and the trend line polynomials are the same, and the regression coefficients are the same. For x to the 0, that's 0. The x value, the x coefficient of x is 0.997. Coefficient of x squared, 0. Coefficient of x cubed, minus 0.313. Coefficient of x to the 4th, 0. Coefficient of x to the 5th, 0.0696. Coefficient of x to the 6th, 0. Coefficient of x to the 7, that's 6.54 times 10 to the minus 3. And coefficient of x to the 8 is 0. This completes the use of array formula, Gauss and error function, SERIESSUM and LINEST polynomial regression to generate the trend line and trendline polynomial of the Gaussian integral.